Here's part 2 of how to solve systems of linear equations using the elimination method. This is a much more complicated example than the first one we used because the x's and y's, they're not all lined up. So that's the first thing we're going to do is we're going to line them up so they're one over another. In this case, I'm going to subtract 4x from both sides on the second equation. So that I'm going to have, let's see, negative 4x plus 2y equals 122. That's going to replace this whole equation. Okay? So now I'll rewrite that over here. We have x minus 6y equals negative 124. And we have negative 4x plus 2y equals 122. Now we need to eliminate one of the terms, either the x terms or the y terms. And I think what I'll do here is I'm going to eliminate the y terms. See how this is positive 2y? If I multiply this whole equation by 3, I will set up a negative 6y and a positive 6y, which when I add the two equations, they'll go away, like this. So this will become negative, if I multiply that by 3, this will become negative 12x plus 6y equals 122. Oops, sorry, equals 366. And now I'm going to use this equation and this original equation. And I'm going to add those two equations. X plus negative 12x is negative 11x. Negative 6y plus 6y is 0y. And negative 124 plus 366. 366 minus 124, 242. It's 242. We're going to divide both sides by negative 11. And we're going to get x equals, anyone? 22. Okay. We'll take that, we'll plug it back in to one of our equations, and you really could choose any, either the two original equations or one of your adaptations of an original equation. Negative 22, right? So let's plug it back into the easiest one. We've got x minus 6y, so that'd be negative 22 minus 6y equals negative 124. So we'd be adding 22 to both sides. And we'd have negative 6y equals negative 102. Divide both sides by negative 6. And y equals 17. So your solution would be the point negative 22, 17.